Welcome to the Level 2 video on matrices. In the Level 1 video, we reviewed matrix addition and multiplication, and we're going to start off by remarking on some of the rules that matrix multiplication has. Okay, so matrix multiplication is not commutative. By that we mean that the matrix A multiplied by the matrix B is in general not equal to the matrix B multiplied by the matrix A. So this cannot be assumed. But the distributive law holds. So that's equal to the matrix A multiplied by B plus C is equal to A multiplied by B plus A multiplied by C. And the associative law also holds. And that says that A multiplied by B times C is equal to A times B, all multiplied by C. And finally, we have to remember that only certain matrices can be multiplied together, and to tell which ones can be multiplied, we use the compatibility condition. Okay, so moving on, let's talk about matrix determinant. So what is the matrix determinant? Well, the determinant is a useful value that can be computed from the elements of a square matrix. And we'll see why it's useful later. And it's denoted by det of A. So some matrix determinant rules . So the first rule is that the determinant of the identity is equal to 1. Remember, the identity is the matrix with 1s across the diagonal and 0s everywhere else. And we write in just meaning the n by n identity. And the determinant of A inverse is 1 over the determinant of A, which is the determinant of A inverse, the determinant of A multiplied by B is the determinant of A multiplied by the determinant of B, so they can be separated, and the determinant of a scalar multiplied by the matrix A is the scalar to the power of n, where n is the size of the matrix A, times the determinant of A. Like we said, for an n by n matrix. So let's have a look at the determinant of a 2 by 2 if A is the matrix A, B, C, and D, then the determinant of A, det A as we call it, is AD minus BC, and the determinant now of a 3 by 3 well, if we consider the matrix plus, minus, plus, and so on and so on, minus, plus, and minus, so on and so on, and plus, minus, plus, and so on and so on, and down as well, then if A was the 3 by 3, A, B, C, D, E, F, G, H, and I, then the determinant or det of A, B, C, D, E, F, G, H, and I. Now this is working around the first row here. So first of all, in this blue box we have A, and then we remove the column and the row which A are in, and we multiply by the minor that's left, E, F, H of I. And now if we remove these lines, then we take B, so we have minus B, and it's minus because of this plus minus matrix at the top. It was plus, then minus, then plus, and so on. So it's minus B, and then we remove the row and column which B are in, and we're left with the minor D, F, G, and I. And then we remove these red lines. Then we plus on C. Again, we remove this row, this column. So we have the matrix minor D, E, G, and H. So computing these 2 by 2 separately, we get A times EI minus FH minus B times DI minus FG plus C times DH minus EG, and that's the 3 by 3 determinant. But it's actually worth noting we can actually start on any row or any column. So you can see we worked on the first row here, A, B, C, but if we had zeros as some of our entries, we might be inclined to choose that row or that column containing the most zeros, because we'll have to do less work. And we'll see an example of this in a minute. So let's have a look at a determinant starting with the second column. So if A again was the matrix A, B, C, D, E, F, G, H, and I, and like I said, this time we're going to work with the second column, then the determinant of A equals, and let's remind us of our plus minus matrix, and we're starting row here, so we want a minus first, so we take a minus B, then we remove this row and this column, and we're left with the minor D, F, G, and I. Then we plus E times removing this row and this column, A, C, G, and I. and then minus h, removing this row and this column with the h, the minor that's left, A, C, D, and F, and then computing these 2 by 2 determinants, we have minus B, DI, minus FG, plus E, times AI minus CG, minus H times AF minus CD. And if we multiply this out and compare what we have with our previous determinant, we can verify they are the same. I'll leave that as an exercise, and we can move on and have a look at an example. Calculate the determinant of the matrix A, where A is 1, minus 5, 1, minus 3, 2, 7, 12, 3, and 3. So our solution is the following: determinant of A, and we don't have any zeros here, so there's no point working down any particular row or column. Let's just work down the first row. So we have 1 times the minor that's left, 2, 7, 3, and 3, plus 5 because it's minus minus, 5 times minus 3, 7, 12, and 3, plus the last minor that's left, minus 3, 2, 12, and 3, and calculating these 2 by 2s, we have 6 minus 21 plus 5 times minus 9 minus 84 plus minus 9 minus 24, and simplifying all of this we get minus 513. So that's our solution. Let's look at another example. This time we can look at a 4 by 4. Again, calculate the determinant of A, where A is the matrix 7, 0, 2, minus 1, 1, minus 5, 6, and minus 2, 2, 0, minus 2, and minus 3, and 4, 0, minus 2, and 0. This time when we calculate our solution, we can see that there are numerous zeros here, so we can speed up the calculation by choosing the row or column containing the most zeros, and that's going to be column 2. So if we choose column 2 here, then we only have to deal with the minus 5, which is in the plus position, so we have plus a minus 5 multiplied by the minor that's left, 7, 2, minus 1, 2, minus 2, and minus 3, and 4, minus 2, and 0. So we have a 0 in the last column here, so we can work down the last column. So we're going to have minus 5 times minus 1 times the minor that's left, 2, minus 2, 4, and minus 2, plus 3 times the minor that's left, 7, 2, 4, and minus 2. And simplifying this all, we get minus 5 out the front, minus 4 plus 8, plus 3 times minus 14 minus 8. And simplifying all of this, we get minus 5 times minus 4 minus 66, which gives us 350. So we simplified the calculation by choosing the rows and columns with the highest amount of zeros. Thanks very much for listening.